Hello, everyone. I hope everyone can hear me. I'm Vignesh, Customer Success and Solutions Engineer from ZEDEDA. Today, I'm going to talk about managing applications in zCloud through an offline profile server. So, the idea of this feature began when we tried to find a way to manage the applications offline. And by offline, I mean when the edge node loses its communication to zCloud. So what happens if the device does not able to communicate to zCloud, and what happens to the applications that's running on them? How do we manage them if the communication to zCloud is gone? And there is this another scenario when edge nodes that needs to accommodate different set of applications that need not run all the time. So for example, take imagine that we have two different Windows applications that are running on the same edge node, but both of them needs to access a certain peripheral. Take a GPU, for example, or USB for that matter. How do we make that happen? How do we accommodate that? Or what happens when the edge node does not have enough hardware resources to run all applications at once, even though they do not, they all of them need not run all the time, right? So what happens then? How do we handle that? So this comes offline profile server. So offline profile server is just a small application running on the edge node. What it does is it lets the user specify which application profile to run. And application profiling is nothing but simply tagging the applications when they are being deployed onto the edge nodes. So when you deploy an application, you just simply tag it with certain name which is going to act as its profile name, and that's about it. So that application is tagged and it has its own profile name. And when the offline profile server is deployed, this is going to take precedence over the Z cloud to manage the applications that are being a part of certain profiles. And what it does, the first thing the offline profile server does is that it halts all the other applications that belong to other profiles, and then it brings up the applications from the profile that the user specified. For example, let's say applications 1, 2, and 3 belonging to profiles 1, 2, and 3 are are deployed on an edge node, and then you go to the profile server and then you tell that profile server, like, hey dude, just bring up the application that belong to profile 1. So what it does is, the first thing it does, it halts the applications app 1, 2, and 3 that belong to profiles 2 and 3, which are not part of profile 1, and then it brings up the application or set of applications that belong to profile 1. The applications that do not come under any profile are not controlled by profile server. They are left untouched, which means when you deploy some applications, if you don't specify any of the profile names, those are not managed by the offline profile server. So how do we configure a profile server? Is that it's a three-step process. The first step is to tag the edge node. So you have some edge node, and in that edge node you're going to deploy a profile server and manage your applications offline. The first thing you need to do is tag that edge node, and it has three tags that we need to provide. The first tag is profile.server.default, wherein you provide the default profile that needs to take precedence, and then you provide local profile server.host, wherein you specify the IP address of the profile server that's going to be deployed on that edge node, which means only then the edge node knows that it's going to have a profile server and it's going to manage the applications offline. And then you deploy, and there is the third tag, which is profile.server.token, which is totally optional. It is used to authenticate the profile server. And then the second step is to deploy the profile server using the host IP that you just mentioned in the edge node. Once the profile server is deployed, this is going to manage all other applications that are going to be deployed using its profile name. And then the third step is deploying the actual applications. When you deploy the actual applications, there is a field where we provide the tag, where we tag the applications, and that is where we provide which profile that this application is going to belong to. So this particular tag, which is local.profile.server.override, is the key, and Whichever value that you're going to give here is going to be the profile name for this particular application. For example, if you give profile 1 for this application when it is deployed, now already the edge node knows that applications that belong to profile 1 can be run and can be brought up online. So when the deployed application also belongs to the profile 1, this application is brought up online. If you provide different profile name for this application, say profile 2, it is not a part of profile 1, so this application when deployed is downloaded, built, and it is kept in halt state until and otherwise. If the default profile server, we explicitly tell that profile server to bring this particular profile up. And then, so what are all the supported operations by profile server? We have these are the API endpoints for the supported operations. This is actually available in the open source uh, Eve link. So we have local profile, get and post methods, which will retrieve the local profile information to the profile information and the profile server, and then the post call will actually switch between profiles. App info API sends the current state of application instances that are running in the edge node, and also purge the applications. And it also has radios API, which will publish the current state of all the wireless network adapters of the edge node. Let's quickly take a look at how this profile server works. Here I have one offline profile server and three applications running, one of which, this app 1, belong to profile 1, and then app 2 belongs to profile 2, and subsequently app 3 belongs to profile 3. So what I'm going to show you is I'm going to log into this profile server, and then I'm going to gently ask this dude to switch between profiles, which is app 1 to app 2, which is profile 1 to profile 2. I'm going to ask the I mean I'm going to log into the profile server. This is my profile server. If you can see, this is the IP address of my profile server, which I have mentioned here. This, this is my profile server. Now, inside this profile server, I we have four applications, one of which is offline profile server, which is running. App 2 is halted, app 3 is halted, and app 1 is running, same as what we see here. Now I'm going to switch between profile 1 to 2. To do that, I'm going to change this file from profile 1 to profile 2, and then the profile server, it will take care of itself, and it will switch between profile 1 to profile 2, which means the app 1 that is running will be halted and app 2 will be brought up online. So that's the nice view of my wand. Let's see the magic unfold. It normally takes a couple of minutes, but yeah. Yeah. Now you can see app 1 is halting and it's halted. App 2 is now running. You can see the state of the application changing. So this way, even when the device loses its communication to zCloud, without access to zCloud, we can have our little inside man in our edge nodes, and we can access our applications, manage our applications. So that's profile server, and thank you everyone for listening to it. I hope you all try it sometime. Thank you. If you have any questions, you can post it now. Ask me, or I can ask my colleague to continue this presentation. Thank you, Ravindra and Mike. Yeah.
That's great, Nitish. Siddharth, I think you're up.
Hey, yeah, thank you, Vignesh, for the nice demo. Let me share my screen now. Okay, thank you everyone for joining ZEDEDA Transform. And today, we are going to cover about the Terraform provider module, which is the Z Cloud. So we will see Z Cloud as the Terraform provider, and I am Siddharth, customer success engineer in the ZEDEDA. So our main agenda today is to look about the Z Cloud as a Terraform provider module. But before that, we will do a quick review of what Terraform is, what are the goals of the Terraform, just basic of the architecture, and then we will try to understand how we can use zCloud Terraform provider to provision or create the VMs or provision our infrastructure on the zCloud. So let us first start with what Terraform is, what are Terraform goals, and what are the key features. So as everybody knows, so Terraform will help us to write, plan, and create infrastructure as a code. So it is like you can just write all your infrastructure in one single file, and you can just provision your day one and day two infrastructure very simply. It's open source. It basically use the HASI core configuration language. It basically creates the dependency graph, so you don't need to worry about the dependency. It takes care of that. And then two basic CLI commands. One is the plan, and second is apply. Plan will help you show your changes, and then applies will help them to execute in order. So this is the basic architecture of the Terraform. So we can see, so Terraform is divided into two parts. So the one is the core part, and another is the plugin. So the responsibility of the core is to read the config. It basically read your configuration file. It maintains the state, and then it converts the graph, dependency graph, out of your config, and then basically over the RPC calls, it talks to the provider, and then finally provider will talk to your upstream APIs to basically create the configuration or create the required resources wherever you want to be. So basically you can see here, so the core will do diff, apply, and refresh, and the plugins have all the functionalities like read, create, read, update, delete, which all the provider provides. So yeah, let's see over what this Terraform provider Z Cloud will help us. So basically, this will help us to create all the configuration on the Z Cloud, and so the currently supported objects which we can use at resources and data sources are the networks. So using this Terraform module, zCloud module, we can create the networks on the zCloud, images, edge nodes, volume instances, network instances, edge app bundle, edge app application instances. So currently only the data store, which we can read only, we currently that is not supported to create. Rest all the things basically you can provision on your zCloud using the Terraform. And projects, creating project device models and users, currently it is in the progress, and we are considering to create them for the future. So, okay, so let me walk you through the what the available objects on the Z cloud, and what is the hierarchy or what is the relation between them. So let's say in the case, let's say we want to deploy the edge app instance. So edge app instance, we deploy it on the edge node, and so this is edge app. It is based on the edge app. So edge app is the template, or we can say the blueprint to create your edge app instance, and then edge app again infers to the images, basically what images we want to deploy on the edge app instance, and network instance basically defines the connectivity to your edge app instance. And this here also again you can see, so image is basically on the data store, so image is referred from the data store, or we can create the content tree out of these images. We can store the images here, then again with the tag edge app instance can refer to this. So this is just the objects which are available on the Z control, and we can use the Terraform to provision all these things to on the our Z control using the Terraform. Okay, so again this is the same thing. So this edge app instance will depends on your edge node, edge app, volume instance, and the network instance. This is basically it depends on. Okay, so let's see. I have some sample configuration files. So let me go and walk you through that. So this is the provider. So basically, I have configured the provider. So we are using zCloud as the provider. Version here I'm using 101. 1.02.2 is the latest. Okay, so let's say one of the objects. Let's refer to the edge app instance. So we will try to deploy one of the image I am referring here as the Grafana app. We will try to deploy that using the Terraform. So this is the edge app instance, and as you can see here, like what we have seen in our diagram also. So basically, this is the app ID. So our edge app instance refers to the app, and then it needs the device ID, and finally it needs the interfaces, basically for which network extent it is going to connect to. So again, if we go to the this bundle, so this bundle consists of, this has a reference to the manifest. Manifest will consist of all your like resources, what resources your AGIP instance needs, and other details, whatever your AGIP instance is. So this manifest file contains load. Let me go and walk you through. So basically the category, which category it belongs to. So you can see here we have the volume level, which we are giving as the Grafana tag, and the interfaces which we are using, and all the resources. So these are the things which our manifest consists, and out of which we create the template. And as you can see here, we are defining the explicit dependency here, because this bundle will is not directly referring to the volume instance. So we need to define the explicit dependencies to create that bundle. And again, you can see to the network instances. So this is how we are defining the port, and it again implicitly refers the device, like which device we are going to create this network instance, and the kind, and what is the type of the network instance. And this is basically the your volume instances. So volume instances, again we are defining the explicit dependencies, because these refers the images, and the block storage, but the block storage refers the content tree. So this is just the basic configuration, very basic configuration and deployment we can do through the Terraform. And let me go ahead and try to run this. So just let me do Terraform apply. So we have created all the 6 resources, and you can see the dependencies. So the initial thing what we want to create is the images, and this instance doesn't have dependency on anything. So the image and network instance got created parallelly. Then finally we refers the image into the content tree. So after that the content tree got created. After that we created the block storage. Block storage again refers to the content tree. Then finally it created the edge app, and again our app instance is dependent on the edge app. So first the edge app got created, and then finally our app instance got created. So this is how basically Terraform and this zCloud help us to manage the implicit and explicit dependencies. So let us go and try to check this on. So you can see like I have created with transform demo edge app instances, which is like it is trying to create. So it is now creating the volume. Okay, meanwhile it is like trying to deploy. So let me show you another feature. Okay, so we can already, so let's say you have already provisioned your infrastructure on the Z control, and now you want to manage it through the Terraform. So basically we can do that also. So this is also the supported function. There are 3 steps which we need to do to basically import your existing objects to the Terraform. So first you need to figure out its ID. From that you can do it either from the UI or the CLI. Then you need to add basically the corresponding resources block for that object in your configuration file, and this is basically the command you need to trigger to basically import that thing. Sorry. So you need to do Terraform, then import, then basically your resource type, the name of the resource, and the ID of that particular resources, and it get successfully. You can see that into your state file, and then you can use the Terraform to manage that. And so basically best practices. So currently what we suggest is like if user is using Terraform, he must not use ZUI or CLI to manage his Cloud objects configuration. It may lead to the corruption of the object. So he should stick either to the Terraform or to the other agents. So these are the couple of helpful links. So you can go to the zdedahelp.zededa.com, where you can find a nice article on the Terraform and how you can start using that. And this is basically the Terraform registry URL, where you can find the different kind of resources, data sources, and how you can use and create them. So thank you. Yeah, this is all the session all about. And Let me try to see. Yeah, and also you can see now this is also online.
Oh, sorry, I was muted. I knew I would do that. Thanks, Siddharth. I'm going to hand things over to Natiz, and we'll go ahead and finish up with the last demo.
Yeah, sure. Hi everyone, myself Nitish. I'm part of the customer success team. Let me start my presentation. Basically, in this session, we are going to see about SSO and how it is supported in our Z cloud. The first thing what we are going to see is in the agenda, what is SSO, how SSO is implemented using OAuth and OIDC. After that, using the SSO from the Z control UI, how we can log in using the identity provider. After that, here I'm using the Azure Azure AD as a identity provider for Z control. After that, I will be showing the how to configure the Azure AD and how to configure the Azure token and secret ID in Z control. And we will see to create a OAuth user, and we will check how it will be authenticated using OAuth SSO. So SSO is single sign-on, which is a authorization service for the customers or the clients to use a single sign-in to use multiple clusters of the Z Cloud. It's basically like using a single Google account to use for the multiple services like YouTube, Google Drive, and other Google services. For SSO, here we are using three types of sessions. It will be using one is for the local session, which we can create a local user maintained by the Z Club. And the second one is the authorization server session, which is for the SSO enabled using the OAuth 2 authorization, which is for the which I'm using the Azure AD. The identity provider session is the person, third party vendor who's providing the identity for the service provider. So as I explained, OAuth is a open identity connect protocol is built on top of OAuth 2, which helps the user to convey the information about them. That means when your user credentials are authenticated with the identity provider, then there will be a TWS token will be generated, which will be stored in the OIDC. Whenever you are moving to other clusters or the child enterprises, the identity will be forwarded. There is no need of logging in again and again. And this will provide you a secure and reliable login in the multiple services of the Z Cloud. So this is the basic structure of the ZEDEDA UI. How we are logging in to the ZEDEDA cloud portal using the identity providers. In our case, the service provider is the ZEDEDA. For the first time, we have to create the user. First, in our Z control, we have to create the authentication profile. In the authentication profile, we have to configure the token ID, then OIDC endpoint, then the client secret. After that, once it is configured, then the same thing it will be generated from the Azure AD. In the Azure AD, you have to create a web application and redirect URL and the client secret in the Azure portal. Those tokens will be, those token ID will be used in our Z control to make the label communication from the Z control to Azure AD. In meanwhile, we can use other identity providers also, like we are supporting Okta and Google Gmail also in our case. So in our case, first we have to log into the Azure portal. Let me go with the demo. So in the Azure portal, here I am using a realm called ZEDEDA.net. That will be configured in the Z control. First, I'm logging into the Azure AD. So here in the Azure AD, Azure Active Directory, I have already created the app registrations for the demo. Here I will be using the Transform Demo Canary, which is the application already registered in the Azure Active Directory. Here you can see the client ID and secrets will be created earlier. How I will be doing this is every time whenever we need to register a new registration, we have to select new registration, and we can give the name, and the platform should be web, and the auth redirect URL will be the cluster which we are using, either it's Canary or Hummingbird. These are all the development clusters in the ZEDEDA. Once we done with the registration, then we have to go to the particular application, and we have to add the secret key. For the Google at all, the secret key, once it is generated, at any time you can view and see the values. But for the Azure AD, only one time it will be generated. At the time of the generation itself, you have to note the values of the secret ID and the value. Once this is done, you can go to the ZEDEDA portal. Here, once you log into the Z control, you have to go to the administration. In the enterprise, you will be seeing the authentication profile. In that authentication profile, whatever the information you have generated in the Azure AD, that you have to provide it here. The client ID which is generated in the Azure AD is this client ID, and the secret ID and the token ID, we have to copy and paste it with the client secret and the open authentication connection endpoint. After that, we will be giving the user roles. By default, whenever a new user gets created, the default user will have the role of sysmonitor. We used to have different roles in ZEDEDA. Sysadmin, sysmanager, sysmonitor, sysoperator. Each role is having different accessibility roles, which is mentioned over here. Based on those permissions, we can access the Z control. Once we configure all these things, then we are going to create the OAuth user. In our case, we all whatever the Azure credentials I have used, I have to create the same name over here. I will be giving Rahul. That is the mail ID I am using in the Azure. So on the profile type, we have to give is OAuth. Rahul at ZEDEDA.net, and the mail ID also same. And after that, for this Canary cluster, this ZEDEDA is the parent enterprise, and we will be having some child enterprises also. For each enterprise, we can configure different roles. For this Docker Rally, I will be configuring sysadmin, and for the other Docker Rally one, I will be configuring sysmanager, which don't have the enterprise accessibility permission. And for the another enterprise, I will be configuring sysmonitor, which he can see all the objects present inside the Z cloud, but he cannot modify those objects. And finally, for the parent enterprise, I will be configuring the user role will be a sysadmin. Once I'm done with that, I will be logging out of this enterprise, and I will be using single sign-on. Once I give the username, it will be directly redirecting us to the authentication server. In our case, already Azure AD is authenticated. It will be for the first time whenever we are logging in. It will ask for the authorization permissions, like what are all the scopes we can provide for it. Once it is done for the first time, it will be stored in the OIDC, so it will be used all the times. So now it is authenticated, and here I can select different enterprises. For now, I will be selecting the test enterprise 2. So now I logged into the test enterprise 2 child enterprise through the single sign-on. Here my user scope will be sys monitor. Likewise, whenever if you want to log into the other enterprises, you can choose the enterprise in this login page itself. Once you are done with everything, you can log out, and you will go to the main login page.